All right, so now for the first example, now that we're familiar with all this, um, we want to graph two things. Number one, we want to graph the sine function, and then we want to graph a sine function that is 3 times that. This is what we call an amplitude change. Okay, so I'm going to do a couple of things here. Number one, I'm still going to write my x-axis at 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is equal to 2 pi. I'm good. Now, because of my amplitude here of 3, I'm going to add some tick marks here and put a height of 3 and negative 3. This is going to be negative pi over 2. So here we go. We're going to start with the y equals sine of x. We already know what that looks like. We know that starts at 0. And you guys, you can do this fairly simply. Like I said, it's repetitive. It goes up to 1. It comes back to 0. Goes down to negative 1. Back to 0. And I'm going to draw this as dotted because this is not our goal. Our goal is not to graph y equals sine of x. Okay, our goal now was to graph y equals sine of 3x. And what's happening is our y values are getting multiplied by 3. So 0 times 3 is still 0. 1 times 3 is now 3. 0. Negative 3. And 0. And literally that's all there is to it. This is a nice smooth curve as best we can. These are not straight lines. And there's our comparison between the y equals sine of x and y equals 3 sine of x. Again, I'm going to do this fairly quickly. This is going to be the same thing in that y equals sine of x, and our amplitude now is 1/2. I am noticing that I blew this on the previous one. Let me go back. They said between 0 and 2 pi. I did do that between 0 and 2 pi. For number 2, I don't want to go, I'm not going to have you go between negative pi and 3 pi, although I'll extend it a little bit, but I'm only going to have you graph 1 period. I think Blitzer says graphs 2 periods. I will be happy if you guys will figure out 1 period. So, again, this is 1, negative 1. My amplitude is 1/2, so I'm going to be able to cut that in half. I don't need to put all the numbers on that. I do need to put 2 pi, pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. I can go negative pi over 2. Okay? My sine function starts at 0, goes up to 1, down to 0, down to negative 1, and back up to 0. And again, I'll draw this dotted because this is not my goal. This was just my pattern. And the more you see this, the easier it gets. The amplitude now is negative 1/2. So I'm multiplying my y values by negative 1/2. I probably should also tell you that the period is equal to 2 pi. I should get in the habit of doing that. If you list that, it helps out a little bit. I know that 0 times 1/2 is still 0. 1 times negative 1/2 gives me a negative 1/2. 0. Negative 1 times negative 1/2 is positive 1/2, and then 0. And again, you can see this graph changes. That wasn't very good. Let's try that again. The graph has a reflection because of the amplitude of negative 1/2. Now I need to make something clear because I sort of misled you. This should not be here. The amplitude is 1/2, positive 1/2. 1/2 with a reflection. Okay, so don't put the negatives in here with the amplitude. Make a note that it's a reflection, not a negative amplitude. Amplitude just means the distance from the equilibrium, or the x-axis in this case. Okay, we have b values. The amplitude was our a values. The b value now changes our frequency of the sine function. The period changes with a b value. So our period changes by dividing 2 pi divided by b. That is either going to stretch the graph or shrink the graph depending on what the b value is. So let's play with that a little bit. Okay, we want to graph, and again, I'm not going to graph between 0 and 8 pi. I'm going to graph between 0 and whatever one period is. Okay, so we're just going to graph one period. I know that the amplitude is 2. I know my b value is 1/2. Therefore, my period is 2 pi divided by 1/2, or 4 pi. Okay, so up here, we're going to graph between 0 and 4 pi because that's one period. Nice part is I can now fill this in. This is going to be 4 pi right here. Half of 4 pi is 2 pi. Half of 2 pi is pi. And now I can count 1, 2, 3 pi for this. Because my amplitude is 2, that's a 2, that's a negative 2. I can go negative pi if I need that. And from here, now that that's all done, the graph is easy. Remember, this is now a sine wave. Sine starts at 0. It's going to go up to the amplitude. It's going to come down back to 0. It's going to go down the amplitude and back to 0. And it really is that quick and easy. You can plug these in using a calculator if you wish, but these things all look the same. Notice that this graph looks the same as the other graphs. The only difference now is what we put on our x-axis, what we put on our y-axis, our domain and range. Now, interestingly enough, our domain here, which they didn't ask us to find, is still negative infinity to infinity. Remember, these graphs continue in beyond 0 and 4 pi. My range, though, has changed. My range goes from negative 2 to positive 2. Okay, if we add a constant at the end, that constant is a shift. Now again, I don't like the way they introduced this. They gave us y equals a sine b x minus c, where b is inside the parentheses. We don't want the b inside the parentheses. We want to pull that out. We want a sine b x minus c over b, right? Or x minus h. So in this case, we know our h, our horizontal shift, is equal to c over b. And remember, it's doing exactly the opposite of what it feels like it's doing. The negative c over b or the negative h tells you we're shifting right. we're including our amplitude and our period change with this. So I know, as I remember, this is not a pretty problem. I'm going to change this problem, and I'm going to go ahead and make this a 4, pi over 4. Okay? Actually, let's make that, I lied. Let's make that a pi over 2. Because we want our numbers to come out easy. I won't make things too ugly for you on a test or quiz. Numbers should go in fairly easily. So here's the first thing I need to do is I need to factor out the 2 from the x. So this becomes y equals 3, amplitude of 3, sine. 2 comes out of the parentheses, leaves me with x minus pi over 4. When I divide pi over 2 by 2, I get pi over 4. This gives me an amplitude of 3, a b value of 2, a period of 2 pi divided by 2, or pi, and a h value, a horizontal shift of pi over 4, and I'm going to tell you that it's to the right because it's minus pi over 4. So, again, amplitude we said was 3, that's negative 3. The period we said was pi, so this is going to be pi over 2, this is going to be pi over 4, this is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4. This is a negative pi over 4, if you will. Notice that we are shifting to the right pi over 4. So I'm going to go ahead and add to this another tick mark. So remember, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This has got to be 5 pi over 4, doesn't it? So 5 pi over 4 put in place because of my shift. Okay, so I'm going to graph everything before the shift. Now remember, you guys, you have an order that you have to graph in. All horizontal shifts are graphed first. Number 1, horizontal shifts. This goes back to chapter 2 or chapter 1, doesn't it? Number 2, all stretches, shrinks, and reflections. And then 3, vertical shifts are last. Okay, vertical shifts are last. Now we don't have any vertical shifts here yet, but just to throw that in there. All right, so if I were to graph my function before the shift, in this case, the stretch doesn't hurt it any, but your graph before the shift starts at 0, it goes up to 1, comes down, finishes up, does this. Now those 4 points all get shifted, right? And to be honest with you guys, it's almost easier to add the amplitude in first. Let's do that. I'm gonna throw the amplitude in first. So this should just be here. 1, 2, 3, 4, 5 significant points. And I'm not even going to draw the dotted line in here, you guys. What happens from here is your shift to the right, pi over 4 units, does this. This gets moved over to here. This gets moved over to here. And these are just all my points. Come on. And there's my sine wave. Notice the sine wave started at pi over 4. my period is still pi units, even though it goes from pi over 4 to 3 pi over 4. I know this gets a little confusing. We will work these for a couple of days. Hopefully we can get them figured out.